Commutative property with respect to addition. We are checking in the set of integers. What are integers? -5, -4, -3, -2, -1, 0. And then 1, 2, 3, 4, 5. This goes to plus infinity on this side, and this goes to minus infinity on this side. So what is the commutative property with respect to addition? It is a plus b. This one, a plus b is equal to b plus a. You have to substitute a and b from the given set of integers. So let's take some values. A is equal to -3 and b is equal to +4. Same we have to substitute on the right hand side. B is equal to +4 and a is equal to -3. We have to check both the sides are equal or not. -3 plus 4 will give you 1. 4 minus 3 is 1. And this is 4 minus 3. 1 is equal to 1. So the left-hand side is equal to the right-hand side. It means that this property is satisfied. Commutative property with respect to addition is satisfied in the set of integers. Let's take another example of integers. Now you can take a is equal to 0. A is equal to 0. And b is equal to -9. Substitute here, a plus b is equal to b plus a. So we are substituting a plus b. 0 minus 9 is equal to b plus a. b is -9. A is 0. We have to check the left-hand side and the right-hand side is equal or not. -9 and -9 is equal to each other. So whatever example you can take from the set of integers, this property will always be satisfied. Which property? Commutative property with respect to addition. Now we will move to another question. This is commutative property with respect to multiplication. Which set is there? Integers. Integers is there. These are integers. Minus infinity is this side and plus infinity is this side, and -5, -4, -3 until here 3, 4, 5 and 0 is in the middle. These are the set. These are the examples of integers. Now we will take a multiplied by b. This is called commutative property with respect to multiplication. A multiplied by b should be equal to b multiplied by a. So take any example of a and b from the given set of integers. A is equal to -4 and b is equal to +5. You can take, or both can be negative. In the next example, we will take both negative. Now you have to check a multiplied by b. This side should be equal to this side. A multiplied by b -4 multiplied by +5 is equal to b multiplied by a, 5 multiplied by -4. Check both sides are equal or not. 5 fours are 20, so -20 is equal to this side also -20. Both sides are same. It means commutative property with respect to multiplication in the set of integers is satisfied. Let's take another example. Now we will take both negative. -10 multiplied by -20. Right? This is called commutative property with respect to multiplication. Check, is it equal to -20 multiplied by -10? Just check. Yes, both sides are equal. Minus into minus is plus. 10 multiplied by 20 is 200. This side also, minus into minus is plus. 20 multiplied by 10 is 200. Both the sides are equal. Left-hand side and the right-hand side, this is equal to each other. So this is satisfied. Commutative property with respect to multiplication in the set of integers is satisfied. Whatever a and b you can take from the set of integers, you can take 0, you can take 1000, you can take 100, 2000. Just check, it will be satisfied in all the cases. Now, next question is, commutative property with respect to subtraction. Let's check this. In the set of integers, -5, -4, this is the set of integers, this side, and 1, 2, 3, 4, 5, this side, it's going to plus infinity, and this side, it's minus infinity. And what is the property? Property is a minus b is equal to b minus a. I am taking a is equal to -3, and b is equal to +4. Check left-hand side and the right-hand side is equal. The property is satisfied or not. A minus b. -3 minus 4 is equal to b minus a. What is b? B is 4. What is a? A is -3. Is this equal or not? -3 minus 4 is -7. And this is 4 plus 3. -7 is not equal to 7. So the left-hand side and the right-hand side, this is not equal to each other. It means that this property is not satisfied. Not satisfied. Commutative property with respect to subtraction in the set of integers. This is not satisfied. Both the sides are not equal to each other. It has to be satisfied in all the cases of the set of integers. Now let's take another example for the set of integers. We are checking commutative property with respect to subtraction. So now let's take another example. A is equal to -100. This side, -100 will come. And b is equal to +100. This side, +100 will come. We are checking a minus b is equal to b minus a or not. This property we are going to check. A minus b is, what is a? -100. What is b? +100. Is it equal to b minus a? What is b? +100. Minus a. A is -100. Check they both are equal or not. -100 and -100 will give you -200. Right? -100, -100 will give you -200. You have to add. When the signs are same, you have to add. 100 and 100 will give you 200. And this side, 100, minus into minus is plus. Now, -200 is not equal to 200. -200 is not equal to 200. This property is not satisfied. Not equal to each other. You can take any other example from the set of integers. Subtraction property will not be satisfied. Right? So now we are checking one more question. Commutative property with respect to division in the set of integers. Right? So we will take a and b from the set of integers. -5, -4, -3. This is going to plus infinity, and this is going to minus infinity this side and plus infinity this side. You can take any number in between them. You have to check A divided by B is equal to B divided by A. This is the property we need to check. So let's take two numbers, A and B. Let's take A is equal to -9 and B is equal to 8. Or let's take both the numbers negative. B is equal to -8, A is equal to -9. Check in the set of division with respect to division. A divided by B, it means -9 divided by -8. Is it equal to B divided by A minus A divided by -9? You can check minus and minus is cancelled from both the sides, so it becomes 9 divided by 8. So 9 divided by 8, the answer will be in decimals. Let's check, and 8 divided by 9 also you have to calculate. So first 9 divided by 8. It's 1.125. This is the left-hand side. Now we are checking 8 divided by 9. 8 divided by 9 will give you 0.888. 889 you can write. Okay, so you have to check both the sides. 8 divided by 9 is 0.889 and 9 divided by 8 is 1.125. They both are not equal to each other. So this property is not satisfied. With respect to division, this property is false. Or you can write false. So what is the result? Commutative property with respect to division in the set of integers is false. Is not satisfied. Let's take another example. Question is same. Commutative property with respect to division. Take another example of A and B. Let's take A is equal to -2 and B is equal to 10. A divided by B. We are checking this. A divided by B is equal to B divided by A or not. A divided by B. -2 divided by 10. Is it equal to B divided by A? What is B? It's 10. What is A? -2. Let's check these two are equal or not. 2 divided by 10 will give you the negative number 0.2, -0.2. 2 divided by 10 will be -0.2. Now we are checking -10 upon 2. It will give you -5. 2 5s are 10 and minus should be there. Minus and minus can be cancelled from both the sides. It's not equal to 5. 0.2 is not equal to 5. So this property is not satisfied. Or you can say it is false. Not satisfied with respect to division. And we can say it is false. It is the same thing. It's false. What is the result? Commutative property with respect to division in the set of integers is not satisfied. The left-hand side is not equal to the right-hand side. You can take any other example from the set of integers. With respect to division, it is never satisfied. In all the examples, it is false. So like this, we have to check commutative property with respect to addition, multiplication, subtraction, and division. In the set of integers, in the set of whole numbers, in the set of any kind of numbers, real numbers, which is given to us.